What if Yellowstone is changing beneath the surface right now? But the change is not what the internet wants you to believe, because one of the most closely watched volcanic systems in North America has recently shown changes in ground movement, hydrothermal activity, and seismic behavior. And scientists are watching closely. Before we go deeper, hit like, subscribe to Earthscope, and share this video with someone who follows earthquakes, volcanoes, and natural disasters. Because Yellowstone is one of those places where a small change can raise a very big question. What is happening beneath the surface? For decades, Yellowstone has carried a terrifying reputation. People hear the words Yellowstone Supervolcano and immediately imagine an enormous eruption powerful enough to transform the United States. That image has become part of popular culture. But the real Yellowstone story is much more complicated. And right now, the most important development is not a giant eruption beginning. It is something much quieter, something happening underground, something scientists have been monitoring for years. Yellowstone is a volcanic system, but it is also one of the largest hydrothermal systems on Earth. Beneath the forests, lakes, mountains, geysers, and colorful hot springs is a complicated network of heat, water, rock, gases, faults, and partially molten material. The ground itself can rise. It can sink. Earthquakes can come in swarms. Geysers can change their behavior. Hot springs can suddenly become more active, and sometimes pressure can build inside the shallow hydrothermal system and produce an explosion. That last part is especially important because Yellowstone recently experienced one. On June 13th, 2026, a small hydrothermal explosion occurred at Biscuit Basin, north of Black Diamond Pool. The event threw rocks into the air, released hot water and sediment, and created new features on the ground. The event was recorded by seismic and acoustic instruments, and later observations showed new fractures and a new thermal pool in the area. USGS. For anyone watching from the outside, an explosion inside Yellowstone sounds like the beginning of something much larger. But scientists make an important distinction. A hydrothermal explosion is not the same thing as a volcanic eruption. That difference could change how you understand everything happening at Yellowstone. A volcanic eruption involves magma reaching the surface. A hydrothermal explosion can happen much closer to the surface when water becomes extremely hot, pressure builds, and the system suddenly releases that pressure. Think of it as a natural pressure system hidden beneath the ground. Water enters the underground environment. Heat from below warms it. The pressure can increase. And if pathways become blocked or conditions change, the water can flash into steam. When that happens rapidly, the expansion can be violent. That can blast rocks, mud, and boiling water outward. It can look dramatic. It can sound terrifying. But it does not automatically mean magma is rising toward the surface. And that is where the Yellowstone story becomes fascinating. Because Yellowstone is constantly changing. It has been changing for thousands of years. The modern monitoring system is designed to distinguish normal changes from changes that could signal a larger volcanic threat. The Yellowstone Volcano Observatory currently lists the volcano alert level as normal and the aviation color code as green. Its August 2026 update reported background seismicity and deformation, with 68 located earthquakes in July and the largest measuring magnitude 3.3. The observatory also reported no significant uplift of the North Caldera rim since January 2026, and only minor overall uplift of the caldera since the beginning of the year, USGS. That sounds reassuring, and it is. But it does not mean Yellowstone is inactive. Far from it. Yellowstone is one of the most geologically active places in North America. Scientists normally record more than 1,000 earthquakes there each year. Many are tiny, many happen in swarms. And much of this activity is considered part of Yellowstone's normal behavior. The key word is normal. Normal does not mean nothing is happening. Normal means scientists have seen similar patterns before and understand them as part of the system's background behavior. That distinction is extremely important because Yellowstone does not behave like a machine that is either off or on. It is more like a living geological system. Pressure moves, water moves, heat moves, fluids circulate, faults shift, the ground responds, and scientists watch those changes using an enormous network of instruments. That network includes seismometers that detect earthquakes, GPS stations that measure ground movement, satellite radar that can reveal changes across the landscape, and instruments that monitor the hydrothermal system. Together, these tools give scientists something that earlier generations never had, a detailed view of the volcano's behavior. And that brings us to the phrase that has attracted so much attention, a new phase. What does that actually mean? It does not mean Yellowstone has entered a countdown toward eruption. It does not mean a super eruption is approaching. It means scientists have observed a change in part of the system. In particular, the northern rim of the Yellowstone Caldera has experienced periods of uplift and subsidence over the past several decades. A recent episode began around June or July of 2025. The area started rising. Scientists detected the movement using GPS stations and satellite radar. Then, in January 2026, the uplift stopped just as suddenly as it had begun. That is not the first time something like this has happened. Similar uplift occurred in the late 1990s and early 2000s. Other periods of minor uplift appeared during the mid-2010s and early 2020s. According to the Yellowstone Volcano Observatory, the recent uplift is most likely related to magmatic activity occurring deep beneath the surface, but the pattern is not considered an indication that Yellowstone is about to erupt. Instead, it provides scientists with information about the dynamic movement of magmatic and hydrothermal fluids beneath the caldera. USGS. That is a much more interesting story than the simple headline, because Yellowstone is not simply waiting for another giant eruption. It is constantly adjusting. The ground rises, then it stops. The ground sinks, then it rises again. Hydrothermal features change, earthquakes occur. Some years are more active than others, and scientists study those changes because they reveal what is happening below the surface. Imagine looking at the ocean from a beach. From the surface, you may see waves, but below those waves is an enormous three-dimensional world. Currents are moving. Water temperatures vary. Pressure changes with depth. Different layers interact. Yellowstone is similar. What we see at the surface is only a small part of what is happening underground. A geyser erupts, a hot spring changes color, the ground rises slightly, an earthquake occurs, a hydrothermal explosion happens. Each event is a clue, but one clue does not tell the whole story. Scientists need to combine many clues before deciding whether the system is behaving normally or moving toward something unusual. That is why the June 2026 hydrothermal explosion matters. Not because it proves a giant eruption is coming. It matters because hydrothermal explosions are a genuine hazard at Yellowstone. They can happen suddenly, they can injure people nearby, they can change the landscape, and they remind us that Yellowstone's surface is not as stable as it appears. In fact, the United States Geological Survey says large and moderate earthquakes and hydrothermal explosions are certain to occur at Yellowstone within the coming decades, while volcanic eruptions are much less likely but ultimately inevitable over geological time. USGS. That statement contains an important lesson. Scientists are not saying Yellowstone will erupt tomorrow. They are saying the volcanic system is active and that future geological events are unavoidable on long enough timescales. Those are completely different ideas. But online discussions often remove the timescale. A scientific statement about something that could happen over decades, centuries, or thousands of years can suddenly become a social media headline suggesting that it is happening now. And that is where fear begins to replace evidence. So let's take a step back. Why is Yellowstone so powerful in the first place? The answer goes deep into the earth. Yellowstone sits above a hotspot. The hotspot is a region where unusually hot material from deep within the earth rises toward the crust. The North American plate moves across this hotspot. Over millions of years, that movement has left behind a trail of volcanic centers stretching across what is now the western United States. Yellowstone is the most recent major expression of that long volcanic history. USGS, and the numbers are enormous. Yellowstone has experienced several huge explosive eruptions over the past 2.1 million years. One occurred about 2.1 million years ago, another about 1.3 million years ago, and another around 640,000 years ago. Those events were enormous. They created massive deposits of volcanic material and reshaped the landscape. The youngest lava flow in Yellowstone is tens of thousands of years old. So when people hear that Yellowstone has erupted before, they often ask the obvious question, when is the next one? But that question assumes the eruptions happen on a predictable schedule. They do not. Nature does not work like a calendar. The time between major volcanic events is not a countdown. You cannot simply take the time since the last eruption and calculate the next one. And this is one of the biggest myths surrounding Yellowstone. There is no scientific timer underneath the park saying that another super eruption is overdue. Yellowstone is not late. It is not waiting for a scheduled date. The geological system operates according to conditions underground, not according to human expectations. And right now, the monitoring data does not show the signs scientists would expect from an imminent massive volcanic eruption. That does not mean scientists ignore the volcano. Quite the opposite. They watch it constantly. And this is why the recent changes are worth understanding, because the best way to understand a dangerous volcano is not to wait for it to become dangerous. It is to study every stage of its behavior, the subtle changes, the small earthquakes, the movements of the ground, the changes in water, the changes in gas, the changes in heat, the changes in hydrothermal activity. All of these observations help build a picture. And sometimes that picture tells scientists something surprising, but But surprising does not always mean dangerous. That is an important distinction. A system can change without moving toward catastrophe. A volcano can have more earthquakes without erupting. The ground can rise without a major eruption following. A geyser can change its behavior without magma reaching the surface. A hydrothermal explosion can happen without triggering a volcanic eruption. Yellowstone is complicated precisely because all of these processes can happen at the same time. And beneath all of them is the heat. Yellowstone's hydrothermal system is enormous. The park contains more than 10,000 thermal features, including geysers, hot springs, mud pots, and steam vents. The water begins as rain and snow that enters the ground. As it moves deeper, it encounters hot rocks and heat associated with the volcanic system. The water becomes heated. Chemical reactions alter the fluids. Pressure and buoyancy move them back toward the surface. Eventually, that underground circulation produces the spectacular features that people associate with Yellowstone. Geysers, hot springs, steam vents, mud pots. These are not separate curiosities. They are visible expressions of a much larger underground system, USGS. And this is where the recent activity becomes even more interesting. A hydrothermal system can change quickly. A pathway can open. Another can close. Pressure can move. Water can find a new route. Heat can redistribute. And suddenly a familiar area looks completely different. That is what happened after the June 13th hydrothermal explosion. New features developed around the explosion site. A new thermal pool formed. Water began behaving differently. New fractures appeared. Scientists installed additional monitoring equipment, including a camera to observe the area. This is exactly what you would expect from a scientific response. Not panic, observation, measure, compare, learn. And that approach matters because Yellowstone has experienced hydrothermal explosions before. The June 2026 event was not the first. There have been larger events in Yellowstone's geological history. Some created large craters, others were much smaller. The danger comes from the fact that hydrothermal explosions can happen without the kind of long warning people might expect from a traditional volcanic eruption. That makes them difficult to forecast precisely. You cannot simply watch magma rising and wait for the final signal. The system is shallow, pressurized, and influenced by groundwater. And sometimes the surface can change rapidly. This is why certain thermal areas are closed when scientists or park officials determine that conditions are unsafe. It is also why visitors are warned never to leave designated paths around thermal features. The beautiful blue pools can look peaceful, but the water beneath the surface can be near boiling. The crust around a thermal feature can be thin, and a seemingly solid surface may not be solid enough to support a person. Yellowstone is beautiful because of its heat. That same heat makes parts of the park dangerous, and that contradiction is at the heart of the entire Yellowstone story. The same underground energy that creates geysers and hot springs also creates hazards. The same magma that powers the hydrothermal system provides the heat. The same geological forces that built the landscape can eventually destroy parts of it. That does not mean destruction is coming now. It means the system deserves respect. And if you are enjoying this deeper look at Yellowstone, this is a good moment to support Earthscope. Tap like if you want more science-based disaster stories, subscribe for future updates, and send this video to someone who thinks every Yellowstone headline means an eruption is about to begin. The truth is more fascinating than the rumor. Now, consider another question. If Yellowstone is currently at normal alert level, why are scientists studying a new period of uplift at all? Because small changes can reveal the architecture of the system. Think of a doctor monitoring a heartbeat. A single unusual beat does not automatically mean a crisis. But doctors still record it. They compare it with previous measurements. They look at the larger pattern. They ask whether the change is increasing, decreasing, or remaining stable. Volcano monitoring works in a similar way. A few earthquakes do not necessarily mean magma is rising, but a sudden change in earthquake frequency, depth, location, and type could become important. Ground deformation alone may not mean much, but deformation combined with a sustained increase in earthquakes, changes in volcanic gases, and other signals could tell scientists that something more significant is happening. The power comes from the combination. That is why the monitoring network is so important. And Yellowstone has one of the most closely watched volcanic systems in the world. Scientists have decades of historical data. They know what normal deformation looks like. They know how earthquake swarms behave. They know that hydrothermal activity can change. They have watched the caldera rise and fall. They have studied the relationship between groundwater, magma, faults, and hydrothermal fluids. This long record gives them something extremely valuable: context. Without context, a change can look terrifying. With context, the same change can become understandable. That is exactly what happened with the recent northern caldera rim uplift. The ground rose. People noticed. The internet reacted. But scientists looked backward. They found similar behavior in earlier periods. The uplift stopped. The area stabilized. and the current data does not show a significant ongoing acceleration toward eruption. That does not make the observation meaningless. It makes it scientifically useful. Every cycle teaches researchers something new, and this brings us to the phrase new phase. Maybe the most accurate way to describe what is happening is not that Yellowstone has entered a new volcanic phase. It is that scientists have entered another phase of understanding the system. They have new data, new measurements, new hydrothermal features, new observations, and a new opportunity to understand how Yellowstone behaves when its underground fluids and heat shift. That is a much more powerful story than saying the supervolcano is waking up, because Yellowstone never really went to sleep. It has been active all along. The earthquakes never completely stopped. The geysers never stopped. The hot springs never stopped. The ground never became perfectly still. The hydrothermal system never shut down. Yellowstone has always been moving. What changes is how that movement appears. And that is why scientists watch the small details. One of the most important questions is whether the system is becoming more energetic over time. Right now, the evidence does not show that kind of runaway escalation. The August 2026 update described activity as background level. That means the latest monitoring does not indicate a volcanic crisis, USGS. But imagine a different scenario. Suppose earthquake activity began increasing dramatically. Suppose the earthquakes became progressively deeper or migrated upward. Suppose the ground started rising rapidly across a large area. Suppose volcanic gas emissions changed significantly. Suppose multiple hydrothermal systems became unusually disturbed. Scientists would not look at one signal. They would look at all of them together. And if the pattern became concerning enough, the alert level could change. That is how modern volcano monitoring is supposed to work. Not through predictions made months in advance. Not through rumors. Not through a viral video claiming that an eruption is days away. Through measurable changes. And this is exactly why the current alert level matters. Normal does not mean Yellowstone is harmless. It means the current conditions are within the range scientists consider normal for the system. There is still earthquake activity. There is still ground deformation. There is still hydrothermal activity. There is still volcanic heat underground. But there is no current scientific indication that a giant eruption is imminent. That is the difference between hazard and emergency. Yellowstone is a high-hazard volcanic system, but a high hazard does not mean a high immediate threat. Think about a coastal hurricane zone. The area may be vulnerable every year. That does not mean a hurricane is hitting today. The risk exists. The emergency does not. Yellowstone works in a similar way. The volcano is real. The hazard is real. The possibility of future eruptions is real. But the evidence does not currently point to a super eruption beginning, and that may actually be the most reassuring part of this entire story, because the goal of science is not to make people afraid. It is to replace uncertainty with understanding. And Yellowstone is one of the best examples of why that matters. The volcano is powerful. The system is complex. The hazards are real. But we are not blind. We can measure it. We can watch it. We can learn from it. We can recognize patterns. We can improve our understanding. And we can prepare. That is why the June hydrothermal explosion should not simply be remembered as a frightening event. It should also be remembered as a scientific opportunity. Scientists now have new information about how the Biscuit Basin system behaves. New fractures, new water pathways, new thermal features, new observations, new measurements. Every one of those details helps researchers understand the shallow plumbing beneath Yellowstone, and the deeper researchers understand the system, the better they can distinguish ordinary changes from genuinely dangerous ones. There is another misconception worth addressing. People sometimes imagine that a Yellowstone super eruption would happen suddenly, without warning, like an enormous switch being turned on. That is not how scientists expect a major volcanic system to behave. A massive eruption would likely involve significant changes in the system beforehand. That does not mean scientists could predict the exact date, but they would be watching for a combination of signals. That is why monitoring matters so much. A volcano gives information. The challenge is learning how to read it. Earthquakes are information. Ground. Movement is information. Gas is information. Water chemistry is information. Thermal activity is information. The question is whether all of those signals are pointing in the same direction. Right now, they are not showing a picture of an imminent super eruption, and that matters more than any dramatic headline. Still, Yellowstone should never be treated casually. The park contains hazards that can kill people without a major eruption. Hydrothermal explosions, boiling water, steam, unstable ground, earthquakes, rockfall, wildfires, and extreme weather. The volcanic system is only one part of the danger. That is why park safety rules are so important. A person does not need to be standing beside a lava flow to be in danger. A thermal area can be dangerous while looking completely calm. A beautiful pool can be deadly A thin crust can collapse. A sudden burst of steam can injure someone. The June 2026 event was a powerful reminder of that reality. And perhaps this is where the Yellowstone story becomes less about fear and more about perspective. We often think of nature as something stable. Mountains look permanent. Lakes look permanent. Forests look permanent. But geological landscapes are never truly finished. They are always changing. The change is simply happening at different speeds. Some changes take seconds. An earthquake, a hydrothermal explosion, a landslide. Other changes take years. Ground uplift, ground subsidence, changes in hydrothermal systems. And some take millions of years. The movement of tectonic plates, the development of volcanic fields, the erosion of mountains. Yellowstone contains all three timescales at once. That is what makes it so fascinating. You can stand beside a geyser and watch an event that lasts seconds. You can measure the ground moving over years. And beneath it all, you are looking at a volcanic system shaped by geological processes that began millions of years ago. So when someone asks whether Yellowstone is entering a new phase, the honest answer is both simple and complicated. Yes, parts of the system have recently changed. But no, the evidence does not show that Yellowstone is suddenly preparing for a super eruption. The northern caldera rim experienced a period of uplift that began in 2025 and stopped in January 2026. A hydrothermal explosion occurred at Biscuit Basin in June 2026. New thermal features appeared afterward. Earthquakes continue. The ground continues to move slightly. But the latest official monitoring places Yellowstone at normal background activity. That is the reality. And reality is often more interesting than the most dramatic version of the story, because the true danger at Yellowstone is not that a super eruption is secretly scheduled. The true danger is that people misunderstand the system. If people believe every earthquake means an eruption, they will panic unnecessarily. If people believe Yellowstone is completely harmless, they may ignore real hazards. Both extremes are dangerous. The goal is somewhere in the middle. Respect the science. Respect the hazard. Do not confuse monitoring with prediction. Do not confuse activity with crisis. And never confuse a dramatic event with evidence of a super eruption. Yellowstone is not a sleeping giant waiting for someone to wake it. It is a dynamic geological system that has been changing continuously. And scientists are watching every day, every earthquake, every movement, every thermal change, every unusual signal. They are building a picture of what is happening below the surface. Maybe the next major discovery will come from a tiny earthquake, maybe from a change in groundwater, maybe from a new pattern of deformation, maybe from a hydrothermal feature nobody expected. That is the exciting part. The next clue does not have to be enormous. Sometimes the smallest signals tell scientists the most. And if Yellowstone teaches us anything, it is that the planet does not announce every change with an explosion. Sometimes it whispers. A few centimeters of uplift, a cluster of earthquakes, a new crack, a change in a hot spring, a new pool, a burst of steam. Scientists listen to those whispers, because one day, if a truly dangerous change begins, those signals could become extremely important. For now, however, there is no scientific basis for telling people that a Yellowstone super eruption is about to happen. The volcano remains at normal alert status, and that should not disappoint you. It should make you appreciate what is actually happening. A giant volcanic system is being monitored in real time. A hydrothermal explosion has given scientists new data. Ground deformation has revealed another chapter in Yellowstone's underground behavior, and the public has a front row seat to one of the most remarkable geological laboratories on Earth. The real story is not that Yellowstone is about to destroy America. The real story is that Yellowstone is still changing, still producing clues, and still teaching scientists how our planet works. So the next time you see a headline saying Yellowstone is waking up, stop for a moment. Ask what changed. Ask how large the change was. Ask whether scientists consider it unusual. Ask whether multiple warning signals are appearing together. And most importantly, ask what the official monitoring agencies are actually reporting. Because beneath the sensational headlines is something much more valuable: evidence. And evidence tells us that Yellowstone is active, it is powerful, it is capable of dangerous events, it has an enormous volcanic history, but right now it is not showing the signs of an imminent super eruption. That does not mean we stop watching. It means we watch more carefully, because the Earth does not need to explode to remind us how powerful it is. Sometimes all it takes is a small movement beneath our feet, a change in the ground, a burst of boiling water, a few seconds of shaking, and suddenly we remember that the planet beneath us is not still. It is moving. It is breathing through heat, pressure, water, and rock. And Yellowstone is one of the places where that hidden motion becomes visible. The next chapter is already being written underground. We just have to be smart enough to read it.